In this video, we'll see the concept of temperature, stress and strain. So suppose we are having a steel rod of length L and suppose the heat is supplied at one end, and because of the application of the heat, there will be expansion of the bar, and that particular expansion of the bar is known as the free expansion, and it is denoted by this delta L. This free expansion will depend upon the coefficient of thermal expansion of the particular material. For example, in this particular case, we have considered steel as the example. So it will depend upon the coefficient of thermal expansion for that particular material. And it is given by L alpha into T. So L is the original length in mm. Alpha is the coefficient of linear expansion, that is per degree centigrade. T is the change in temperature. So this coefficient of linear expansion will explain for 1 degree centigrade change in the temperature, what will be the increase in the length of that particular material. So L is in mm, alpha is in per degree centigrade, that is 1 upon degree centigrade, and T is the change in temperature. For example, original temperature is 20 and now it becomes 50. So 50 minus 20, that is nothing but 30, that will be the change in temperature. So here this degree centigrade and degree centigrade, it will get cancelled out and you will get delta L in mm. So this is the concept of temperature, stress and strain. So when this expansion is prevented, then and only then the stress will be induced. So for example, this is the expansion because of the increase in the temperature due to the heat supplied. But if this expansion is prevented, then and only then the stresses will get induced. So if it is a free expansion, then there will not be any stress that will be induced in the material. So let us see. Suppose E is equal to temperature strain, then we know that it is delta L upon L, that is change in length divided by original length. So L and L will get cancelled out from the numerator, so we'll get alpha into T. Let us call this as our equation 1. Sigma is the temperature stress and E is the modulus of elasticity, that is sigma upon E. So sigma will be equal to E into E. Small e will be equal to alpha into T, that is E alpha T. So we know the value of temperature strain and we know the value of temperature stress from these equations 1 and 2. Now force will be equal to stress into area. So sigma into A will be the value of force. Now sometimes the support slip or yield by an amount of delta. Then the expansion prevented will be equal to L alpha T, that is free expansion minus the yielding of that particular support because of the application or because of the external force. So yielding means slight deflection which will be there. So L alpha T minus delta will be the value of delta L. Now in that particular case, delta L you can strain you can calculate as delta L upon L, and value of delta L is L alpha T minus delta. So it is A minus B upon C, that is A upon C minus B upon C. So it is L alpha T divided by L minus delta upon L. Cancel out this L, so it is alpha T minus delta upon L. So that will be the value of temperature strain if the support is shifting slightly or yielding slightly or slipping slightly. We have considered this equation, so you can see this is capital E that we have written as it is, and this small e is nothing but it is alpha T minus delta upon L. That is the value of temperature stress. Now suppose we are having a steel rod of length 1000 mm and it is heated through 50 degrees centigrade, and we have to find out what will be the stress and nature of that particular stress if ends are fixed. Take alpha is equal to 12 into 10 raised to minus 6 per degree centigrade. So you can find out the answer for this. Let us see the steps for this. So length is given as 1000 mm, temperature is 50 degrees centigrade, sigma we have to find out, alpha is given as 12 into 10 raised to minus 6, only alpha is there. Then E will be equal to alpha into T. Just substitute the values because E is alpha is 12 into 10 raised to minus 6 and T is 50 degrees centigrade. Find out this particular value. Now alpha T into E. Value of E is not given, but it is a steel rod, so we can assume that particular value. So it is 2 into 10 raised to 5 Newton per mm square. So substitute the value of alpha T, that is E, and into capital E. Capital E we have assumed. So after substituting both these values, that is value of E and capital E, we will get the value of stress, that is equal to strain multiplied by modulus of elasticity. Now suppose we are having a rod of length 10 meter and it is initially at 10 degrees centigrade and its temperature is raised to 70 degrees centigrade. Now if the expansion is prevented, find the magnitude and nature of the stress induced. Take alpha is equal to 12 into 10 raised to minus 6 per degree centigrade and modulus of elasticity capital E is equal to 210 kilonewton per mm square. Now length is 10 meter, that is 10,000 mm. Temperature, change in temperature is final temperature minus initial temperature, that is 60 degrees centigrade. Modulus of elasticity is 210 into 10 raised to 3 Newton per mm square because it is given as kilonewton per mm square. Alpha is 12 into 10 raised to minus 6 per degree centigrade. Now we know that stress is alpha T into E. Value of alpha is 12 into 10 raised to minus 6. Change in temperature is 60 and capital E is 210 into 10 raised to 3. So find out the value of stress. Now as the expansion is prevented, we can say that the given particular rod is subjected to compressive stress. We will see this particular concept in the next figure of the composite bar. Now suppose we are having a square rod of 10 mm into 10 mm in cross section and 1000 mm long and it is fixed at both the ends, and we have to find out what will be the end reactions. Now as it is fixed at the ends and the bar tries to expand, the fixed end will offer a reaction to that particular expansion. The rise in temperature is 50 degrees centigrade and E is 2 into 10 raised to 5 MPa and coefficient of linear expansion, that is the property of the material, and that is alpha, and it is equal to 12 into 10 raised to minus 6 per degree centigrade. So area is 10 into 10, length is 1000 mm, force we have to find out or reaction we have to find out, and temperature is 50 degree centigrade. E is 2 into 10 raised to 5 MPa and alpha is 12 into 10 raised to minus 6 per degree centigrade. First find out the value of strain, that is alpha into T. Value of alpha is 12 into 10 raised to minus 6, that is this particular value. Temperature is 50 degrees centigrade. So you can easily find out the value of the linear strain or rather temperature strain. Then stress is equal to strain into capital E or alpha TE. Substitute all these values and you will get the value of stress in Newton per mm square. Force is equal to stress into area. So you can find out that value of P also. Find out all these value and let me know the calculations that you have made. Now suppose we are having a metal rod 16 mm diameter, 2 meter long, and it is held between two supports at 100 degree centigrade. Find the pull exerted when the temperature falls to 50 degrees centigrade. So if the support is not yielding and if the support yield by 0.5 mm, take capital E is equal to 110 GPa and alpha is equal to 12 into 10 raised to minus 6 per degree centigrade. Now diameter is given as 16 mm. So we can easily calculate the area, that is pi by 4 d square. Length is 2 meter, that is 2000 mm. Force we have to find out. Initial temperature is 100 degrees centigrade, final temperature is 50 degrees centigrade. So drop in temperature is T1 minus T2. So that will be equal to 50 degree centigrade. So T is equal to 50 degree centigrade. Capital E is 110 into 10 raised to 3 MPa, because we have to convert GPa into MPa and then we have to multiply by 10 raised to 3 for this to convert GPa into MPa. Alpha is 12 into 10 raised to minus 6 per degree centigrade. Now, what will be the value of P, that is pull exerted, if the supports they are not yielding? So find out the value of E, that is strength, that is alpha into T. Then stress is alpha into T into E, and force is equal to stress into area. Now this is the case when the supports are not yielding. Now if the supports slightly move by an amount of 0.5 mm, then what will happen, that we have to see. So suppose delta is 0.5 mm, that is the yielding distance is given as 0.5 mm. Then we know that the deflection will be equal to L alpha T minus delta. So L alpha T, that value we already know, minus delta. So that value comes out to be 0.7 mm. So E will be equal to delta L upon L. So that value comes out to be 3.5 into 10 raised to minus 4. 10 raised to minus 4, and strain is not having any unit. Stress is equal to E into E, that is 38.5 Newton per mm square tensile stress, and then force will be equal to stress into area. So value of stress is 38.5 and area is pi by 4 d square, that is pi by 4 into 16 mm diameter is given. So pi by 4 into 16 square multiplied by sigma, that is 38.5 Newton per mm square. So that value of P comes out to be 7740.88 Newton.